Hello everyone. So in this video we are going to talk about binary stars. So people have been observing the sky since many centuries and they have seen stars which are very close to each other. A very famous example of such a star in India is that of Vasishtha and Arundhati. So there are these two stars which are very close to each other. The brighter one is Vasishtha and the fainter one is Arundhati. And there are many stories about these two stars, about how they are always seen together in the sky, so on and so forth. In the Western culture, these two stars are called Mizar and Alcor. So people have been observing these stars, and since they are seen very close to each other in the sky, it is very natural to think that they are somehow linked to each other. So this is what people understood by binary stars then, that they are seen close to each other in the sky and they might be somehow linked to each other or gravitationally bound to each other. So this brings us to an interesting category of binary stars, that is optical doubles. So these stars are two or more stars which appear like a binary star, but they are not actually gravitationally bound to each other. They just happen to lie along the same line of sight, but in space, in 3D space, they are actually far apart from each other. This is because when we look in the sky, we just get to know the angular separation between the stars, but we have no idea about the radial distance of these stars from us. So these stars appear to be together in the sky, as I said, because they happen to lie along the same line of sight. Now how do we know that they are not real binaries? So we look for two things. The first thing is that we measure their radial distance. So if they are very far away from each other, that is, if the radial distance between them is very large, they are obviously not gravitationally bound, they are out of the gravitational influence of each other and they are not in an orbit around each other. The other thing that we check is that we check their proper motion. So we check if the proper motion is too high. Now what happens if the relative proper motion of these two stars is very high? They are not obviously gravitationally bound to each other and they will drift apart in space slowly. If the proper motions are totally unrelated, then we have a similar situation. Whereas if the proper motion is exactly alike, that is, they are identical, then these two stars are moving with same velocity in the space, that is, their paths are parallel to each other and they are not going around each other. So this is how we understand that these two stars are not gravitationally bound to each other, but they just look close to each other in the sky because they are along the same line of sight, and they are called as optical doubles or line of sight binaries. So as you can see in this image, this is Mizar and Alcor. The brighter one is Mizar, the fainter one Alcor, in the constellation of Ursa Major. So Mizar and Alcor is a very famous example, and this was the first binary star to be observed. Later on, with the invention of telescopes, people started looking the skies through the telescope, and what they found out was that many stars which look singular in the sky, they are actually binaries or there are more components to it. So these are few examples here that you can see. In 1782, William Herschel actually made a catalogue of these pairs of stars with an aim to observe them over a period of time. So these pairs of stars, one of them is brighter, the other one is a little bit fainter. His aim was to observe these brighter stars, brighter as in the nearer one, as it was understood then, and fainter, which means it is farther away. So his aim was to observe these brighter stars and look at their parallactic motion as compared to the fainter one. While doing so over a period of years, what they found out was most of these pairs were actually gravitationally bound to each other, or they were in an orbit around each other. So this brings us to another category of binary stars, that is visual binaries. So visual binaries are binary stars which are gravitationally bound to each other, and they can be resolved as 2-point sources either through telescope or naked eyes. So these must be resolvable visually and they are gravitationally bound, which also tells us that these pairs, these binaries are comparatively closer to us because they should be resolved separately, and also the distance between them is a bit bit larger than other binaries, because again they need to be well resolved. Now what all we can observe? So the first thing that we can measure is their separation. So these binaries are obviously going around each other. So the separation between these two stars is going to increase and decrease as time passes. So we can find out their minimum and maximum separation, and from that we can calculate their periapsis and apoapsis. The other thing that we can measure is the position angle. So now what is the position angle? So as I said, in a binary star, one of the star will be brighter, the other one would be fainter. The brighter star is called the primary star and the fainter is its component. So you draw two lines from the brighter star, you draw a line from the brighter star to the north direction and from the brighter star to the component. The angle between these two lines in the direction of increasing right ascension is your position angle. So you can measure the position angle. You can also measure the difference in magnitudes, you can measure difference in colors. So most of the two stars in a binary system, they have different colors. Like for example, the star Albireo in Cygnus. So there are two stars, one of the star is goldenish in color and the other one is bluish green. So you can measure the difference in colors. Now as I said, these two binary stars, they have some separation between them. So from Kepler's law we have T square proportional to R cube, right. So greater the separation, more will be their period. Now this puts some bounds, upper and lower bound, on how far the stars can be situated from each other. So to be visually resolvable, they need to have certain distance between them, but they cannot be too far because they also have to be gravitationally bound. So there is an upper bound on this. Also there is a lower bound, because the closer these two stars are, the harder it becomes to visually separate them. So there is obviously a lower bound on the distance, which means there is a lower bound on the period. For example, this star BD has the smallest period, that of 1.7 years, which can be visually resolved, and the other example is that of Castor from Gemini constellation, which has a longest period, that of 420 years. So these are the two constellations where you can see the two stars that I talked about. This one is Ursa Major. So Mizar and Alcor are a binary star situated in the tail of the Ursa Major. So if you look at the second last star in the tail, the brighter one is Mizar and the fainter one is Alcor. So the other example that I gave was about the star Albireo in the constellation of Cygnus, the swan. The beak of the swan is actually the star Albireo, and if you focus your telescope on this star, you will actually see two stars. As I said, one of them is golden and the other one is greenish blue. Thank you.